Hello everyone. Today is the solution lecture for solution for whatever we have discussed in week 3 assignment. In week 3 we have talked about primarily different types of climate data set, which can be your reanalysis product data or climate projection data or historical data, can be gridded format or point format like that. So, we have given an assignment on exploration of climate data set from reanalysis product and climate models. So, I will give you a very brief overview about different data sets which are available, which can be used for analyzing the historical climate behavior of a certain place, as well as we can also use these data set for multiple other data sets or future projection data set for quantifying what is the impact of climate change on different weather properties in the different scenarios like that. So, first we will start with reanalysis product. So, the one of the most commonly reanalysis product is we called ERA 5. So, when you type ERA 5 in Google, you will get this link. So, you have to click this particular link, ERA 5 hourly data on single levels from 1940 to present. So, when you click this particular link, you will get this particular site where there are interface where we can get the information about what is the ERA 5 data sets is available here. So, this is basically developed by ECMWF, which is European Union sponsored data set. So, here what you have to do is you can go through the data set and their different properties. For example, ERA 5 is a 5th generation ECMWF reanalysis data set for global climate and weather for the past 8 decades. It is basically present from 1940 to present, and data is available 1940 onwards, and ERA 5 replaces the previous version, which is called ERA interim reanalysis data. You can also see that there is an image which shows that 2-meter temperature distribution across different parts of the world, which is derived from this ERA 5 reanalysis data set. Now, how do we access this data? So, if you go down in this data, so this is basically suggesting that this data is gridded format. It is a regular latitude longitude grid which has a uniform grid size. It is a global coverage. The resolution is around 0.25 degree for atmospheric layers, 0.25 degree roughly around 25 kilometer, and for 0.5 degree into 0.5 degree for ocean waves. Then we have again 0.5 to 0.5 degree for atmosphere, which is a slightly different variant of this data, and then 1 degree and 1 degree also. So, there are multiple different types of variables which are also there. We will go through one by one in this particular website. So, we can select here this particular tab. This is called download, and in this tab you see that there are multiple types of data sets which are available, which are there. We can use it and we can download the data. For example, here we can select the reanalysis product, then we can select, let us say, total precipitation, then we can go to further. So, there are so many different types of data set. For example, here it is a temperature property, we have wind property, we have mean rates, different types of variables. Then here we have mean rates. So, I have selected the total precipitation here. Then in the below we can select the number of years from where we need this type of data set. Suppose we are selecting 1940 1941 and 1942, 1943 and then 1944, 1945. So, what will happen? It will basically download the data of total precipitation across whole globe from 1940 to 1945. Now, you can also select which month you wanted to do that analysis. Suppose I am interested in monsoon month. So, then I will select June, then July, then August and then September, that is called JJAS. Then after that we can also select in different months which particular day of the data set we are required, or maybe we can select all the months, all the dates which are there in the months. Then we can also select the time periods, because this is the hourly data. Therefore, for each different 1 hour we have one variable or one value of the selected parameter. So, here we can select that and then we can get the data for all the hourly values for different days for our monsoonal months. Then if you click it here, it will basically generate the data for entire globe, which is of course will be bigger in size, file size. But when you select here, you can also mention the latitude or longitude of one particular region. That will basically crop the data for that particular region, and then we can do the analysis like that. Then further we can also select what type of the data set we required. We can click netcdf file, or we can click grif file. Both has a a specific format where this type of the data set can be stored, and you can download zip file or unarchived version, and then we have to log in it, and then basically it will you can download the data set. So, this is how basically one can download the ERA 5 data and can start the analysis. There is another alternative option of downloading ERA 5 is, we will go to Google again. Here if we type, let us say Google Earth Engine, you will get this particular link. If you click it here and particularly click it here, dataset. So, Google Earth Engine is a kind of a platform where a large dataset for satellite, remote sensing or reanalysis data, observed data, climate data, everything is available. Most of the datasets are available, and you do not have to download the data. You just have to click the data or write few lines of code, and then that data will be generated and you can analyze that data for any particular region. So, suppose this is the Earth Engine data catalog where I am searching the ERA 5 data. Now, you can see it here in this Google Earth Engine, you also have ERA 5 datasets are stored. So, which means you can use the ERA 5 data directly from Google Earth Engine and then can start the analysis. For example, if I open this data, ERA 5 daily aggregates climate reanalysis data. So, daily aggregates means in the previous example we have shown that the ERA 5 data was created for hourly basis. Now, this is a daily aggregate, which means we are summing up all the 24 values for one particular day, and we will get one single value for one single day, like that. So, this is the ERA 5 daily aggregate data. Here you will see that the data sets is available here from 1979 to 2020. You can also check the band and you will see that there is a different types of data sets are available. For example, mean 2 meter air temperature, minimum 2 meter air temperature, maximum 2 meter air temperature, dew point temperature, total precipitation, surface pressure, and various different other parameters which we can see that. So, here we have also a snippet or a code here, which basically can be directly we can write in Google Earth Engine code editor, and that can directly download this data. We have to mention which type of the band we are using it, and that basically can generate that type of the data set. Now, we will go back to the main catalog of ERA 5 where we yes. So, again we are here in the data catalog. Now, we have to click here the view all data set. So, if you write here again, just a minute, yeah. So, if you write here again ERA 5, so we will get other type of the data set which are originated from ERA 5 as well. For example, ERA 5 land daily aggregate data climate reanalysis. So, if you select this data, it is started from 1950 to 2025, very recently. We have band information, and here in this data we have lots of other variables which are stored. So, using this data set you can do much more detailed analysis for any particular region. Now, I am going back again, or I click here view all data set. There is another type of the reanalysis data set is called Terra. Terra climate. If you click this data set, it will also show that there are several types of different variables which are available, and that can be used for some sort of historical data analysis using the Terra climate, which is also a sort of reanalysis product. So, these are the reanalysis product. Now, let us suppose, so this is all about the historical data or historical weather simulations using different model with the observed data set, and we are clubbing it together to get the reanalysis product. Now, if you wanted to work on, let us say, future projections, what sort of the data set we need that. So, for this we can click CMIP6 data, and in this data we can basically go to this particular site, not this one, we have to go to, yeah. So, we can go to this CMIP6 search interface, and in this interface we will get that multiple different types of data set. For example, we can select different types of variables here. We can select different types of products, forcing products or model output, or we can select different types of models which are climate models, and then basically we can select different types of variables. For example, let us type here precipitation, or let us say rainfall. So, here basically based on this website we will be able to get the future projections data set that can be used for different types of scenario assessment. Now, I will introduce one another website which basically gives you a graphical representation of these climate data without downloading it. So, that is called the website name is dap.climate information.org. So, this is the website where we can click it, and then we will get the some sort of future projections data set. So, here you see that first of all, this is a disclaimer that this website is using not the correct boundary of India. Therefore, this is just a disclaimer before giving you more brief introduction of this data set. Okay. So, in this data access portal, we can get information about what is the spatial pattern of historical and future data set. So, if you look at here this data, future or past data. Let us say if I select past data and if I select here indicator, for example, I am looking at the temperature and this is annual, you can select, or maybe you can select different types of temperature, minimum temperature, maximum temperature, heating days, frost days, tropical nights, like that. Let us say I am selecting only temperature. Here you can see that these are the different results which we observed. So, most of the region in India is observing temperature more than 25 degree. If you look at the Himalayan region, here temperature is relatively lower, but overall in the globe, so we have major of region where the temperature is very high, significantly high according to this data set. So, here if you look at different future data. So, when you click it here future data, you will be able to so you can okay. So, now you can click here the past and future, and if you click let us say future data, let us say I am selecting future 2011 2040 and for scenario 2.6. Okay. Now, you look at here that this is the temperature data set which is showing different colors, very light colors, which is basically suggesting the rise in the temperature from the base period 1981 to 2010. In the base period, the historical data which we have already seen, and from that base period this much amount of increment we will observe in the different parts of the Indian region. Now, if you just increase let us say different scenarios, let us say I am clicking SSP 8.5, and this scenario you will see that in the future you have around 1 or 1.5 degree increment when I am saying the highest increment scenario. Let us say I am saying what would be the future when we are using let us say 2071 to 2100. So, if you click it here, it will tell you about most of the country region of Indian territory is showing increment of let us say more than 2 or 3 degree, right. So, that is basically suggesting the temperature. Now, you can basically click the rainfall, precipitation, and you can basically look at precipitation annual and for let us say this, and you can look at here which region is likely to be experiencing heavy precipitation in the future scenario. Let us say if you look at this particular region, this whole region like that, here there is a 40 mm 40% change in your increment in your rainfall compared to your base period. So, this is basically we can use these websites to get an idea about what is exactly how we can use this data set for multiple different purposes. Now, I will introduce another website. I will go to Google again, then there is a website developed by IIT Mandi team, which is a very informative website, incline.iit Mandi. Let us see whether it will appear. Yes. So, incline IIT Mandi website. If you click this website, you will see lots of different apps there. Let me go to climate impact app here. Okay. Now, you look at here. So, this is now this website showing the correct boundary of the India. So, okay. So, now let us see. Okay. So, this is the website where it is showing you multiple different region in India. Here you can use multiple different properties. So, only 3 properties: precipitation, temperature and minimum temperature, and then you can use multiple different models, or ensemble mean means average values of different models. So, if you select any region in India, okay, so let me select here, let us say this is, I am selecting Bhopal, I am selecting this point here. Now, if you look at here, it shows that this is the data set of, you know, Bhopal region of your precipitation. So, this is your the rainfall data for historical period from 1980 to 2020 or something, and after that you have all the data set which are generated from 2 different scenarios, SSP 2.45 and SSP 5.85. Now, you look at, this is historical data set which we have already observed, and this is basically a climate projected data set where we have different scenarios. So, this is basically suggesting that in the future scenarios we will experience, is likely to be, we will experience a very heavy amount of rainfall under different scenarios, and the trend is continuously rising, which means the Bhopal particularly is likely to experience increase in the rainfall in the future conditions also, which means more flooding or urban flooding conditions, more rainfall induced vulnerabilities we are likely to be faced in future scenarios according to this data set we can get. Let us say we can select multiple different models. Let us say I am selecting only Access CM2 model, and now this map has been already updated, which is only showing the result from, I think, Access CM2 model. Now, you can also see that what is the historical model data and what is the observed data. Now, if you look at here, most of the previous time we have the model was not accurately captured the historical data set. Therefore, it suggests that Access CM2 is not able to correctly match the peaks. However, there is a pattern which is basically covered by this particular data set. Therefore, we use the ensemble mean data, and that is basically showing the overall behavior of rainfall of a particular district. So, here we can see that there is a data set which is historical period and for the future conditions, and for the future conditions we have data set for 2 different scenarios, SSP 2.45, SSP 5.5, and using this information you can assess the what is the overall trend of the data set. So, this is how basically we can generate this data, and if you let us say click annual and then download link, you can download this data and you can do further analysis using this data set. So, using all these websites, all these resources, all these data repositories, we can download historical data set which are coming from, let us say, reanalysis product or observed data set, or different types of model we run and then we produce the historical results like that. Or maybe we can use, let us say, future projections data of climate models, and you can use that data set for some sort of insight about your particular region or any particular region where we can analyze it, what is the rainfall pattern is likely to be changed, or what is the temperature pattern is likely to be changed in the future conditions. So, this is how basically you can solve this assignment number 3, and you will get more insight about these types of data set. Thank you very much for your listening.